Hello, my name is Rayan Talib. I'm here to show a video of Newton's first law. Newton's first law states that an object in motion will stay in motion unless acted upon an external force. And an object at rest will stay at rest unless acted upon an unbalanced force. So, for the example that I'll be using, is this soccer ball. Where is it? There's this soccer ball. The soccer ball right now is at rest and will stay at rest unless it will act upon an external force. What will the external force be? It will be my foot. So now it is at rest and I kick it. Now the object is in motion. Okay, so as you can see, when I kicked it and it hit the wall, this wall, say if it was like a goalpost, for example. That is another external force that causes the ball to stop. If that was not there, it will be moving in the same direction, same speed. Well, not same speed due to the wind, but say if there was no wind, for example. It will be in motion, it will stay in motion until it will be acted upon, whether it's strong winds, someone stops the ball. If no one stops the ball, there's no winds, and it's an empty field, the ball will keep going on, it won't stop. Thank you very much. That is Newton's first law of motion. Hello, my name is Rayan Talib. I'm here to teach you the laws of motion, specifically the second law of motion. The second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This means that the greater the force, the greater the acceleration. But the greater the mass will produce a less acceleration with the same amount of net force acting upon the object. For this example, I'll be using this cart. This is it's not a sharpened cart, but it's the cart that I use at work, which will work the same. I'll be using this hallway to move around, and I'll try to apply the same force. So say I'm walking back, going all the way over here, and I'm pushing it. I'm not using that much force. I'm pushing it very easily. It goes up obviously, and it goes up easily. But if I were to add these boxes over here, which has spins inside, which will create this shopping cart, like will increase the shopping cart in mass. Now I won't do one, I will do two. So I gotta put these on the shelf either way. There you go. So I'm gonna go right back to where I was. I'll try to apply the same force I used. And you can see it was much more slower, and I let go, it stopped. As you can see, it stopped much more faster. And that is the second law of motion. Hope you learned something. Thank you very much. Rayan Talib. Hello, my name is Rayan Talib. I'm here to present Newton's third law of motion, also known as the law of action and reaction. This states that for every action, there is an equal and opposite reaction. This means that when two objects interact, they exert forces on each other that are equal in magnitude and opposite in direction. For the example that I'm going to be using will be a ball. How will I use this as an example? Very simple. When the ball bounces on the ground, just like that, it exerts force onto the ground. And the opposite reaction that is happening is the ground, with the same magnitude, like the same force that the ball is, hitting the floor with, like that, it exerts that with the same magnitude, but it's right back in the opposite direction. Which is why every time we bounce the ball, it's gonna land right back to the open. With more force, it will be much more hard. Like now, come over here. Like now, I'll throw it here, very high. When I bounce it easily, it doesn't really go that much high because I'm not putting enough force on the ball, which like the magnitude of it will be very easy, very soft. Just like I saw now, if I slam it to the ground, all the way up in the air. That is Newton's third law of motion. Hope you learned something new today, and if not,